relations and whatnot. When we're talking about inverse relations, and we're talking about the inverse functions, it's basically the idea of flip-flopping x's and y's, okay? Your domain and range change places. So for your when you're looking at your graphs or your tables, all your values of x just switch to become values of y, and values of y switch to become values of x. You're just flip-flopping. By doing that, if you are on a graph, if you're plotting your ordered pairs, what happens is that they become symmetrical about the line y equals x. And that's where a lot of that graphing stuff comes into play, is that in order for functions to be inverses of one another, they become symmetrical about that line. And that's also why I think there was some examples in here. I'll come back to that in a second. When you did it algebraically, I'm going to go out on a limb and assume that flip-flopping x and y and resolving isn't a terrible task to do. That's pretty straightforward. So the inverse of y equals 2x minus 4, you go x equals 2y, add 4, divided by 2. So you have 1/2 x plus 2 is y. That's how you found your inverses. Flip-flop x and y, resolve. Exact same thing. It's the same thing. I just read this 1/2 x because whenever I see that, I think in terms of slope intercept form, I can walk a 1/2, 1/2, as opposed to having to take a rule numerator. Now, wait, what?
What?
Did you do this yesterday?
Is this what we already did?
Yeah.
Oh.
That's what I'm just kind of. That's why I'm just going to kind of fly through this. Did you guys? One of the things that also comes up is that I don't remember in the video. Did I mention what happens with the negative value? Remember, when you have a negative fraction, what they're normally doing is they just put it out in front of the fraction bar. If you write it as -2/3, that means the same thing. Remember that negative can float to whether the numerator or denominator, or they put it in front of the fraction bar. Any one of them is fine. So when you find the inverse of this one, subtract the 6, excuse me, and then to undo multiplying by a fraction, you multiply by its reciprocal. Reciprocal of -2/3 is -3/2. Remember, we're not doing opposite reciprocals here. You guys will have a tendency to do the opposite
That's what
reciprocal.
you said in the video too.
Really?
Yeah. Weird.
Isn't it weird? And then it's just distributing back. It's -3/2 x plus 9. And then that equals y. It's really eerie when I can still do stuff when I'm not here. I forgot to ask you, why did you email me in the video?
Because I accidentally emailed it to you and then to Mr. Beverly.
Okay, because I saw that Beverly in his notes that he said he put his laptop up and played it. I wasn't sure. I didn't know because I wasn't sure if the video was going to play for you guys because it was on my old YouTube channel that all of a sudden halfway through the school year last year became invalid for the domain of D428. God forbid you guys can do your homework and learn anything. For what? The approval thing? Yeah, if you use that, and then I also uploaded a change in the approval rating, so you should have been able to watch it, so. Whatever. Now, this is where I wanted you guys to understand what that -1 value meant. If you look on your calculators, you guys all have the button X to the -1. That means inverse. That's where all that comes from. If something's not happy, it gets flipped. Same basic principle here. Now, in order to verify that things are inverses of one another, if functions are going to be inverses of one another, that means you'll be able to substitute in to each other. That's where we get that f of x, or sorry, f of f prime of x, or f to the -1, or f inverse. If you substitute in, for example, if I start with the inverse equation, 1/2 x plus 2, and then I surround that by the f equation, by doing that and distributing and solving, you should get, well, what's 2 times 1/2? 1. So I get x plus 4 minus 4, and I get x. If I do the same thing on the other side, I start with the f of x equation. So I write out my 2x minus 4, and then I surround that with the f inverse equation. Distribute out, I get half of 2, half of negative 4. Which means if I get x for both of them, that shows that they're inverses of one another. That's how you verify that you have an inverse. Okay? Yeah, yeah. And I knew that was in there for that. And that's where it comes into play with that idea of graphing. Because if you take these two equations, and we can show this real fast in your calculators if you like. Take your calculator out and I'll show you how this works. These two are pretty easy to put in the calculator. I don't remember, in the video, did I show you guys how to use the calculator for any of this?
No.
I didn't think so. It's not something we did a ton of. So I go to my y equals. Let's put in these two equations. 2x minus 4. And then 1/2 x plus 2. What's the quicker way to type in 1/2 in the calculators instead of putting fraction? 0.5. Whenever I'm doing a fraction that's easy, and I'm just graphing it via the calculator, just use, sometimes decimals are quicker, just to type, that's all. Plus 2. And then the last one I want you to put in is y equals x. Graph the x. Isn't it good though when you forget your x? Hey, I don't know who had their calculator charging in the back there, but that charging stand wasn't even plugged in, so I don't know how well it charged for you.
Charged?
Well, I plugged it in this morning when I got here. So if I hit enter or hit graph, you should see, well, gotta change my.
It's 1/2 x.
Did I mention I have a head cold?
No.
Okay, let me know to remind you, okay?
Wait, when did we start with the third x?
These, what this value of x here is going to show that the two graphs are symmetrical about the line y equals x. Now, if I didn't screw this up, I gotta change my window. If I go to a 10 by 10,
By 10 by 10.
Do you have your finger with a record
it should look clean now. There's the blue, red. Basically what's happening here is that every point that's on either, for every ordered pair that's on the blue or the red line, they're symmetrical about the line in the middle of the black one. So all of those are, every single ordered pair is inversed over that. That's how this stuff works. That's where it came in the idea of being able to graph. Yes, sir?
And then it's like 4, 4.
Yes. Excuse me. So when you're looking at graphs, what you're going to wind up doing is you graph both of them, and then if you have graph paper, it's a little bit cleaner to be able to see some of this stuff. And that way you can kind of go from there. I don't remember off the top of my head what the problems themselves look like, but we'll show this here in a second. All right, what's the next part here? Verify if they're inverses. Did you have a problem with?
Yeah, we had that.
Did you have? Were you okay with using the exponent rules about showing inverses? I know that the new textbook doesn't go into very much detail about anything with exponent rules, which is kind of disheartening because I like exponent rules because they're fun. They put the fun in functions.
Did you make that?
That was so bad.
Did you make that? I don't remember if you made that.
But we're okay with this substituting back and forth here, verifying. Power relations. Here's what happens. What happens here is the reason that they have to put in this disclaimer about x has to be greater than or equal to 0 is because in order for things to be a function, they have to pass that vertical line test. Remember that? Really? Oh, Well, here's why. Because if you have your original equation, if it doesn't pass the horizontal line test, when you flip it, it won't pass the vertical line test. So if you look at, everybody agrees that the graph of x squared is this. Now, if I inverse that without the disclaimer of all values of x being greater than or equal to 0, what happens is you get this. Okay? Now, if this disclaimer wasn't here, this doesn't pass the vertical line test, which means my inverse is not a function. Now, if my inverse wasn't a function, that meant that my original problem wouldn't have passed the horizontal line test. That's what that meant. So if your original function, without disclaimer, doesn't pass the horizontal line test, the inverse of it will not pass the vertical line test. Does that make sense? That's where that was coming from, okay?
Why is the inverse sideways and not like upside down?
Because the A value is positive. So when you do your inverse here, if you do it without disclaimer, that means you have y equals x squared to start, which means the inverse would have been x equals y squared. So by taking the square root of both sides, you get plus or minus square root of x is y. Plus or minus square root of x, if you look at it, that's going to go this way and this way. Okay? If you throw that in the calculator, plus or minus, you can't, there's no plus or minus button, but if you do the positive square root of x and the negative square root of x, you will show that it goes out and under. Okay? But by looking at it with a range or domain restriction, when you're looking at your graph to start with, this one is looking at for all positive values of x. So I'm only looking at x squared going this way. I don't care about the negative values of x. So if I look at just the positive values of x squared, when I find the inverse of it, that means I'm only looking at the positive square roots. So what happens is you get this. When you take your x squared equation, positive, everybody's okay, it does that. Now, you get y equals x squared for x greater than or equal to 0. Do the inverse of that, you're going to get x equals y squared, which means the square root of x is y because I'm working with that domain. When I graph the square roots, now, we haven't done square root graphing yet. We're going to probably start that maybe tomorrow. Play it by ear, see how it goes. When you're graphing square roots, the easiest thing to do is to pick values of x that are easy. For example, perfect squares. 0, 1, 4, 9. 16. Because what's the square root of 0? What's the square root of 1? And so on. Same thing here. When you graphed 0, here's 1 and 1. Here's 2 and 4. Here's 3 and 9. And so on. So when I go the other way around, I'm at 0, 0, 1, 1, 2, I'm sorry, 4, then I'm at 2. So this curve does that, which gives you that symmetrical line y over x, y equals x. So they spin around each other. Yeah, like, it's easier to show in the graph stuff. So you go back here. Oop. Let's do y equals x squared. And let's do y equals the square root of x. And let's do y equals x. But I want to change my window. I don't want any negative values of x. I don't want to look at them. So I'm just going to make my y value, I'm sorry, my window, my x min to be at 0. And if I do that, there's your x squared, there's your y equals, and there's your line. So it goes under and across, and they just, every one of those points on the blue versus red line are all going to be equidistant to the line y equals x. They're all symmetrical about that line. That's how that stuff's going to look. Huh. It depends. I mean, a lot of this stuff, it's a lot of these things when we start to worry about the graphing. The graphing is just kind of to show how the visual, to make sure that you can see how the symmetric stuff works. When it comes to actually graphing square roots and cube roots, there's an easier way to do it, which we don't need the calculator for. A, H, and K. It keeps coming back like a bad penny.
Intersect with 1, 1.
Go figure, because what's 1 squared? And what's the square root of 1? And what's when 1 equals 1, all that happens. Math!
You almost sound like the count from Sesame Street.
So, it. You okay?
Yep. That had a good day. I'm good.
Here's an air 5, makes you feel better. I don't want me to knock you out of a chair. So this is where that idea where you guys were asking about the horizontal line test. So if I look at the idea to tell whether or not the inverse of 1/2 x cubed minus 2 is a function, what we do real fast is throw it your graphing calculator. Okay. If you throw out the graphing calculator, you get an idea of whether or not you're going to have a function to start with. And what was it? 1/3? No, 1/2. Sorry. So it's 1/2 x to the third minus 2. Oops. Change my window back to a 10 by 10. Now you might recall when we did some polynomial function stuff. This is kind of looking at the idea of our dance move things from before. In this case here, it's doing the down up tail, and it changes direction in the middle on the y-axis. At any point in time, does this fail the horizontal line test? No. It looks like it might, but it's still increasing through here. What this horizontal line test tells you is, like I was getting at the beginning, if you take a horizontal line and at any point in time this touches more than 1 point, that means that the inverse will not be a function. Okay? Because it doesn't pass the original function doesn't pass the horizontal line test, that means that the inverse won't pass the vertical line test. That's all that that's all that meant. So if you know it's going to pass, then you can go ahead and find the inverse. So here, by flip-flopping x and y, we have x equals 1/2 y cubed minus 2. So you get x plus 2 times 2, and then it's a cube root. So you get the cube root of 2x plus 4 as the inverse function. Okay. If you wanted to be so crazy as to throw that in the calculator, then you could see that those two graphs are symmetrical about that line y equals x. What is that? Cube root button, there is math 4, and it's 2x plus 4. Should be so lucky to see. It's kind of a cool looking graph. Fancy.
Slightly volume is not going to be this symmetrical.
It's symmetrical. It's just that you have to remember that you're looking at a rectangular image that is not a square resolution. That's why. Okay. So inverse, no problem. And then you had the homework stuff. So, in the homework then from the old textbook, what do you want to, did that help to kind of revisit that real quick? Because I know sometimes I talk too fast, and if I have a head full, I'm a little bit slow. That's it.
Just like notes, like a negative x, you take
You shouldn't have a negative, because those should be domain restricted if you're taking the square root of the negative. If that happens, you should have a domain error.
So weird.
So you look at, if it was doing that, it should have said, and it might have had on there x had been greater than or equal to 0, so it should not have come up. Unless that when you subtract it over, I know there's some problems where you subtract over, you might have the square root of 2 minus 2x, and that could be in the root because then it just shifted, and it's reflected. We just haven't done the graphing of it yet, that way it's, I think the old textbook we graphed before we did inverses, which I think makes a little bit more sense because if you understood the graphs of the nth root problems, it might be easier to see why these inverses are occurring. So next year, I will graph before I do inverses. Questions though, what else went? Yeah, man.
Can you do one of the graphing ones?
Specific.
It was like 49, 51, and 53.
55.
This was 7-4, right?
I didn't do nothing. Well, I didn't do anything.
I didn't do anything.
All right. Excuse me. 49, you said?
Yeah, it was 49, 51, 53, and 55. You can do any of those.
Oh, okay. So
I just don't understand.
in this case here, it says graph this, then use the graph to determine whether or not it's going to be a function. If the inverse is going to be a function. So if I look at the graph of y equals x plus 3, do you agree that the graph of y equals x plus 3 is this? Okay. In that graph, does that graph pass the horizontal line test?
Yes.
Yes.
So will the inverse of this be a function?
Yes.
Yes.
Yes,
That's all it is.
that's all it is.
Are you serious?
That's a heart attack.
The last one.
Wait. I just get kind of confused when you're drawing 3 lines.
Well, the 3 lines, what I'm showing here with the 3 lines is that you're taking by looking at by looking at these fancy pictures in the calculator,
Air?
when you look at the blue equation was our f of x. There's your f of x. The red is f prime of x, the inverse. The black one is y equals x. So what happens here, or f of x equals x, I should say. What happens is that for every point that's here and here, they are equidistant to here. Because this ordered pair, this xy, is y x. That's all that is. That's all that's showing. By looking at it, you can kind of see how they mirror themselves through. That's what the idea of by looking at it in the calculator, after you're done, just see how it looks. That's all. That's the only reason why we look at it in the graphing calculator. And what Maddie was getting at, does that make, that's all you're doing. I mean, for most of those, you could have just thrown it in the calculator, literally. I mean, here you have x squared plus 1. X squared plus 1, you know that it's a parabola up like a cup, correct?
Yeah.
Does it have a domain restriction to it?
No.
So that means you're looking at both negatives and positives. So will it pass the horizontal line test? So will the inverse be a function? There you go.
Wait, so like if it has like a squared or like a cube root, it won't be.
Squares you're going to be fine. Will cube roots be an issue? I'm sorry. Squares you're going to have an issue because you have to have a domain problem because you can't take square roots of negatives. But cube roots, then you're looking at when you have something that's cubic. If you take the cube root of something, you can have negative values because think of it this way: the 2 cubed is 8, and the cube root of negative 8 is negative 2. So you can do cube roots of positives and negatives.
If you put the cube root into the calculator, that's what you get.
Right. You have your dance moves. Your tails are down up. So if you inverse it, you're going to pass that horizontal line test. Okay? That's what I was looking at there. Don't quit your day job.
That's my thing.
Go here.
I was talking to Ray. It was not all about you today, man.
Well, it should be something.
Does that make sense about why I was asking you guys to graph that, to look at the graphs? Because if you're able just to look at the graph and think about it, you'll know right away whether or not you'll be able to take the inverse. Okay?
I don't really understand that.
looked at my watch, I didn't know what time it was. Trying to think what else there was in it. It's just, I don't.
Can I have another day now that it makes more sense?
I'm thinking so. What did I have you guys do for homework wise out of this one?
A lot.
At the end of the, all the.
17 through 30. Why don't you guys do the even junk out of this then, just to make sure we nail it down? Why don't we just do the same junk today? That way you've got. If you nailed this stuff out yesterday, it's gonna be a breeze. If you were still a little fuzzy, now it's gonna be even easier. Let's just do the evens out of the same chunk of these problems. Let's do it for tomorrow, and then we'll do the we'll start graphing tomorrow. Does that seem decent?
Okay, do you want us to do 16 through 32?
18.
Or
18.
18 through
18.
32?
I think let's see if it makes sense here. Let's see, it would be 18. Let's do 18. Yeah, do 1832. Yeah, that makes sense.
Just do 18.
And then 38 through 56.
We'll do 18, 32, even, and then let's see. What does the other ones look like? 38.
Wait, but 54 is an absolute. Oh, I just used one.
38 to 50.
Oh, and think about it. What's an absolute value graph look like? Think about it. You know what this looks. What's an absolute value look like?
Isn't it a positive?
That's a U.
Yeah. It's a from. Oh, it's a V.
So will that pass the horizontal line test?
Well, that's easy.
Yeah, we'll go 54.
54?
Yeah. So what is that? 38, 54. And then we'll put all that together. Then tomorrow we'll jump back into the new textbook and talk about the graphing. What I want to look at with the graphing for these things is that I might do it as far as doing square roots tomorrow and cube roots Thursday. That way we don't try to do all of it at once because I want you guys to be able to do this without using calculators. So if there's a calculator or non-calculator, what part do you think would be the non-calculator? You guys are SFIC.
You would do that.
I'm still, because the way I look at it is, what day is today? Today's Tuesday, right?
Yep.
So you did the last bit of functions here today, so then tomorrow's Wednesday, Thursday, Friday. We'll do graphing here. I have this probably won't take all of Thursday to start that, so I have some review stuff that I'm going to get to you guys also on Thursday. We might actually be able to get most of both the parts of the graphing done, and that might give us a little better bit of a more review here. But the only thing is that since we only have Monday, Tuesday, I want to leave this as a buffer, just in case anybody is, dead here, and they have to take a test here. So we might have to test it here on that Monday, and that'll give us a buffer just in case. That way, it's not on that Tuesday. And, if anybody just wants to play hooky, go ski. Why are you so worrisome? Julie, do me a favor. You step on her foot so she stops complaining about her knee.
And that's why. I'm really sure it's breaking off.
Does that seem? I think that's what we were talking about before I did yesterday too.
Cry.
I mean, it's not the greatest plan, but it's a plan. I'll also I'm starting to put together some review problems as far as the entire semester is concerned. I'm going to start. I'll probably have that stuff posted out Friday-ish. I'll just pop them online. I'll have those. I'll have some like that CUDA stuff that I give you guys with the answer sheets. I'll have that thrown in there. Yeah, it'll all be PDF files and stuff. I'm gonna be there, and then Tuesday then with the buffer, and then we have what? We come back from break. We have 5 days before finals. I mean, it's more review than I've ever had to ever do because I wish we had finals before break. Damn. Or even last year, when we came back from break, we actually had like 8 days before finals, so I was able to actually finish up half of a unit before we got to the final stuff. If I had 8 days, we could have done that, but 5, no es bueno. It means it's not very good.
Yeah, I was thinking.
I wasn't sure because you kind of.
It takes me minutes sometimes.
Wait, did you say you were gonna have like extended response all the time?
I don't know yet. I'm kicking that idea around. I'm-
Project.
Don't hurt it.
No, I'm kind of thinking the idea of, I don't know, maybe, I don't know, I haven't figured that out yet. Maybe I don't know if I want to do like a linear programming problem, or like a find all zeros type thing, like a non-calculator thing, because that's a good thing to do. I don't know, it's a good question, like, I've been kicking around that idea. We'll see. I'll give you advance warning, how's that at least? I won't tell you the day before.
Will you tell us the problem? Just like what kind of problem it's gonna be?
He won't. Extended responses are the worst because like if you don't know how to do the problem, like what do? Yeah.
You make up something and then hope that he gives you partial credit for trying.
Take pity upon your soul.
You start crying. Yeah. I feel like he doesn't like crying very
Get an
much.
Emma.